introduce myself, I'm an Italian software developer. I work in the UK in London for a company called Wasoku, and you can find already the slide this GitHub repository where there will be also the code that we show now. First of all, some benefits that we will get from test-driven development, unless you already do it. How many people more or less already do it? Yeah, many people. So, first thing is that you will forget to use the debugger. You will not use it anymore. It's painful, annoying, and really the worst thing for me, for the developer. Because you will know exactly when something fails, where is the failure, and you will be able to track it down very easily. You will write better code, because using test-driven development, the code that we write will be more modular, more functional, and better in every sense. And you will only write what you need. You will not start writing 10,000 things which you will never need anyway, but you will only write what you actually need to pass the test. And most importantly, you will sleep at night. That's very important for me, because when I don't have tests, I have no idea if my code actually works. Even if I'm very confident I've done a good job, the only thing I can say, if they ask me it works, I can say, you don't fail for now, but nothing else. So Python is a really great language, but there are a few things which are missing from other languages which are more static. So we have duck typing, which means that we have no type system whatsoever. We have no exception checking, we have no compilation step, so we don't get any of the warnings or errors that you get from a compiled language, which are nice sometimes to have. So you get a lot of rope to hang yourself. So first simple example of something that can happen and probably will happen. So you have a simple function, smart function, which will, under a very rare condition, will fail a reported error. Otherwise, it will do something right. You see any problem with this?
The test is missing.
Huh?
You should start with a test.
No, apart from that. Now the problem is that this is arg big O, this is arg0. So then at runtime it will fail miserably when the right condition, it will not report any error. And this is, unless you use PyLint or something like this, which you should use, you will never notice this. So yeah, this is the goat for the testing group, by the way. This is the symbol of the testing group of Python. So another example, which happened to me many times, is when you want, for example, a function which takes a list of something, and instead you pass a string instead of a list of strings. This will not fail at all. We just return you a list of characters uppercase, which makes perfectly sense, but it's not what you want, probably. Again. So what are unit tests? Unit tests are very small tests which are isolated, which are localized to a certain portion of your code which you want to test, and they don't have external dependencies. It means that you should not set up any database, anything external, touch the file system to prepare the test. And they must be fast. I think speed is very important, because you should, for test-driven developer, you should be able to run tests all the time, continuously. Every time before you commit, for example. So you know that you're not breaking anything all the time. This is, for example, not a real unit test, because I test a function report, which internally we need to access to a database, to a MySQL database. So what I do before running the test is to set up, put some values here into the database, and then I check that the result contains this. This will be probably slow. If you have like 200 of these tests, it will be terribly slow, and you can't run them all the time. So unit testing gives you a change of perspective, in my opinion. It's not, the question is not anymore how can I get this working, but it's how do I test it. And I think this question is more important, because in the end you want to be able to prove that what you've done is correct. You don't want just to show, okay, you don't fail, that's enough. So once you start to have this question, since programmers are very lazy people, as you can see from the picture, so the question is, what is the easiest thing that I can test? Because I don't want to write 10,000 lines to prepare something to run a test, as I did before, also because it's slow. The easiest thing is probably pure functions, like simple, stupid addition, no? Here the code is missing, sorry, it disappeared. Okay, well, if I have a function which is just a mathematical function, all I need to do is a table of input, output, and loop over and see that the output is what I expect to be. That's the simplest case. So here, for example, simple sum and subtraction. I can just do some assertion on the input output. I can even check that my sum, that subtracting from the sum of a, b, and a is equal to b for some range of values. In some other languages, for example, like Haskell, you have libraries like QuickCheck that, since the type system is so strong, they will allow you to range over a subset of the input and output domain, and then will automatically test all possible values, for example. You can do that in Python. There are some libraries also in Python. But this is so the problem is that it's not so simple. Life is not so simple, sadly. So we have side effects. So we have a side effect every time a function, in addition to returning a value, also modifies some state or has an observable interaction with calling functions of the outside world. This is a complicated definition, but basically anything that touches the file system, global variable, static variable, in C, all these things are side effects. And this makes life hard to test. This is a simple example of a global variable. So the first time I call this function, I get 3. The second time I get 4 with the same input. This is not a pure function, and this is harder to test. The first possibility to solve this problem. So the problem is that now we want to remove these external dependencies and make our function pure again in some way. So one first possibility is that we use dependency injection, which is a technique where in the constructor of the object you inject some function or other things which are needed by the object, and then you can choose what to pass in. For example, here we have a function report, which would use the function ask time to print the time, and it simply returns a string with that. So the problem is that I can't test it so easily because ask time depends on the time. So I can write this like this, and then I pass by default ask time to time func, but in a test I can just create another function here on the fly and then pass that, and now I know I can test it easily. So the problem with this, I think, is that this is ugly because you are creating some attributes in the object which were not really part of the logic of the object. So the only time which this makes sense to me is when you have actually like a strategy pattern, when this makes sense to be different values also in the production code. If the only reason you are putting this is to be able to have a unit test, then probably you shouldn't do it. Also because in Python we have better ways to do it. The better way is mocking. Before I explain how to do mocking, just a simple introduction about how you can change the binding runtime of Python objects, and that's what mocking is, why it works. So, for example, I have a file called library.py, which has a run func which calls this library function, so in the same file. And now from another file, I want to somehow test this, no? But what I can do is that I can change dynamically. So first time I call this function, it will be the original one. But then I assign to libfunc something else which I just defined here. I call it again, and it will use the new one to show you that it's true. Since you don't believe me. So if I do, which one was it? No. No. What's happening? I don't see the output.
Wait and wait.
Let me change theme. All right, yeah, here it is. So, okay, but now you can see anything. Can you read? Okay, I have a prog.py. Yep. So running in the given library and running in change function here. So this is very powerful. How I got that. Yeah, it is very powerful because it allows you to change a runtime bindings and even of something that you already imported. As long as when you run it again, you change the binding before. So that's I think the basic mechanism of which mocking is based. And the only problem with mocking, I think, is that every time you mock something, you are one step away from your real system, because you are not anymore testing the integration between the different parts, but you are creating something similar of what you have that should return the same thing. But when you change the real implementation, this integration might not work anymore. That's why you also need integration tests. So one nice concept I found in a talk from Gary Bernard is a functional core imperative shell, which means that basically you can write your code in a functional programming way in the core, so then you don't have side effects, and then have an imperative shell around which does all the side effecting part. That's probably the best way to do unit testing also. So here's an example of how you do patching and mocking things. Suppose I have a function which just lists over a list of files and then yield values if x is in the name of the path. Now I don't want to rely on the fact that my current directory has some files. I just want to, so I can patch lib listdir with a new function which simply takes an argument because it has the same signature of this one, and then returns 1 to x. So then I know here I can pass anything because it will not be actually used, and then I know that I should get only one value, one element in the result. Another example with a mock object. I have, for example, a complex object with a method which is very expensive. I don't want to run the unit test. And then I have an object which in this constructor will create this object and call this method. I don't want to run this method to try things. So what I can do is to create a mock object, and I can even pass this something very nice of mock library from Microsoft that I can pass autospec, which means that you will create an object that will behave exactly as this one, except that it won't do anything useful. So I don't even need to tell that the method should be callable. It will do everything automatically. Of course, you can do it also by hand. But the nice thing of this autospec is also that you don't have to remember to actually change again every time the mock object when you change the code. So it will be automatically synchronized. So yes, again here I patch this complex object with this object, and then I can do it, and it will not call the real one. So yeah, another thing about patching is that this thing is a decorator, and will reset the status as it was before, before the call, after the function is finished executing. This is very important, so you don't leak the status through different functions, and you can test them independently. Alright, this is the test-driven development cycle, cycle. So first of all, before you start, you just think about the simple test that you want to write, and then focusing on the requirements only. While you think about the test, you already, of course, you already have to think about some kind of implementation, but you will keep it simple because you just say, okay, I want this, I want that this function will return this thing. So then you run the test and make it fail. And this is important. I'll show you later why this is important. Then you make it pass, writing some code to make it pass, but not too much. Then you refactor, and then you go back to 1. Let's show you this. So the first step is quite simple. I just show you something about the make it fail part, because I think many people, I also don't do it all the time, but it's quite useful. It's important to do it because the problem is if you have a test which you think is doing something but it's not, and then you have a failure, you're never going to check the code that you think you tested already. So this is an example of what you can do that will fail miserably. So suppose here I thought that this empty was a property. I can assert that Q empty is true. The problem is that empty is not a property, so this will always be true because this is a function, it's like method, and will always evaluate to true. So as I can show you here, if I remember which one it is now. Yeah, this one. Pass the test. So if I run it now, yeah, it passed. And now suppose, it's important to make it fail because this is the right thing to do, but before I do this, in theory, I want to make it fail. So now we run it again, it should fail, but it doesn't. So now I know that something is wrong with my test. Right. Now we run it again and it fails. So unless you actually see it failing, you will not be sure that is again same problem. Okay.
5 minutes.
Okay. All right. So another possible example is about refactoring. I will not show everything. So this is an example of function which does way too many things and is difficult to test. So for example, here it connects, it reads from the file system some output, then it loops through this output and it checks for some lines and append to the result. And then it connects to the database again and do things. I just show you the last implementation of what it should become, in my opinion. So there are a few steps. So the last step is basically you have 3 functions instead, where one is run ls, one filter output, and one is update to database. Where the cool thing is that filter output is now just a pure function which takes a list, which takes some output, an iterable, which can be anything, and returns a list. So then I can add a simple test, as I showed before, for pure function. And the other things I probably still need other ways to test them. But with the factoring step, we know how to do things. Another great library is coverage Py from Ned Batchelor. And yeah, the basic idea is that it sets a tracer function, runs a script, keeps track of all the lines that have been executed, and then it shows a report of the things that have been covered or not by. And this, as simple as this, if you want to use nodes, so just pass the option with cov report HTML, and it gives you a great report with lines that didn't get covered by. Yeah, I want to show you something about this, but I don't think I have time. Yeah? Yeah? This is okay. Suppose I have a file called show coverage. Yeah. So here is a smart division function which does simply stupid things. It returns a float if it's if the result is float, or an int if it's int, and then you raise an exception if they're dividing by 0. So now I run the nose. I run this command. Yeah. And now I can see the result here. Coverage report. Okay, this is the file actually. And it shows you that here I have this test, and it shows you that the only thing which I'm actually testing is this. These are missing, right? Because now I just pass a 0, and here it fails and raise an exception. If I add these other two, it will. I don't have to show everything. It's not important. But now, if I uncomment these two, it will also show you that also this and this will be covered by the. Alright, conclusion, tests are good, tests are also documentation, because you know where to look, how to use the API and so on. Testing can be very easy in Python, because it's a language. And testing also alleviates the fear of changing things. When you want to refactor, sometimes I start bigger factoring, I still know that when the tests are passing again, I know that I'm fine. Otherwise, I probably wouldn't do it in the first place. And testable code is better code, and now they go to the second. Yeah, so some links which will show as link in the GitHub. And yep.